My name is Jisheng Wang, and I'm heading the data science and Marvis development work in Mist. It's my first time to networking field day, so super excited. As Studio mentioned, I'm going to use some real-world examples to explain how really Marvis leverages state-of-art AI and ML technology to solve wireless and wired problems. Okay, let's get started. As you all know, AI is one of the most talked terms in the tech industry during the last few years. And recently, people are even arguing whether this AGI, artificial general intelligence, is going to take over humans' job. So keep this chaos aside. I believe Marvis, as the first true AI-driven network operation solution, together with a domain expert, should be automatically detect, troubleshoot, and remediate most of the network problems. Or in other words, the goal of Marvis is to free up the network admin from the daily repetitive job, to focus on more high-level and complex problems. To do that, as Bob mentioned, we created this event action framework. This is actually a very extensible and also powerful framework. We started developing this with only the AP data, AP events and AP stats. And recently, we added the switch data from the Juniper switch integration. And in the future, we plan to add more third-party data source, like Redis server logs, DHCP server logs into this. And this is going to really be the brand behind Marvis. So the more data you feed into it, the more knowledge or intelligence Marvis will have to answer this end-to-end network problem. So if you take a look at this diagram, you actually can think a data funnel from the left to the right. So from the left side, as the input data, we want to take as much variety and quantity of data as possible into this system. Certainly cost is the issue. That's the reason we built this layered framework to really filter down the information you need to handle and pass to the user. So, for example, when the data reach to the event framework, that's probably 10% of the data from the input data. When the data reach to the troubleshoot root cause and action, that's certainly then 1% of the input data. So, but come back, rather than just the other AI tools just showing you the dashboard, flood of the events, we actually added two more layers here. One is this called automated troubleshoot, in which we use various spatial and temporal correlation cross event to find the root cause of the problem. The next one is this is a very brand new action framework, with which we can either take automated action to fix the problem if it's a Juniper or Mist device. The root cause is there. Or we give users suggested actions to guide them fix the problem in the neighboring system. Next, in addition to the framework, Marvis also uses various of machine learning and deep learning models. I'm not going to go through the details here, but one thing I want to point out here, the two deep learning models on the top, reinforcement learning and the neural network, are really the foundation of the third AI paradigm shift, which happened in the last 5-6 years, and are also the key technology behind those other AI systems like Alexa, AlphaGo, Google Home. And we use both of them inside Marvis to solve the radio management and the anomaly detection problems here. Okay, let's really go to examples. So this is a survey we have done with some of our customers regarding all of the top user impacting problems during their daily work. And you can see from the list, in addition to those normal, I would say, network infrastructure problems like switch, AP, Redis, client issues actually also become one of the top impacting problems admin needs to handle every day. And then next, I'm going to use these 4 examples: anomaly detection, missing VLAN from switch, and bad clients and persisting failing clients to explain really how Marvis can automatically detect, troubleshoot, and remediate these problems with domain expert. As Studio always said, wireless has only 2 problems, surprising. User cannot connect, user can connect but cannot pass traffic. So this is about the user cannot connect the problem. This graph shows all of the total connections, client connections, and the fed connections from a distribution center of a large retail customer during the whole month of October. So you can see there are more than 4,000 clients on this site with over 6,500 failures a day. So this is a very noisy environment. Rather than just, most of people do with this is set some threshold, then I'm going to alarm you when the failed connection goes above some threshold. This is pretty noisy, and this is not actionable. So Marvis actually analyzes each of the failed connections, really try to find the root cause and the suggestion to help user clean up their environment. You can see the top graph here is the total observed failed connections from all of the clients from that side. There's some of the seasonal signals in this graph mixed with these occasional jobs and dips there. So the first thing Marvis does is use this called a Fourier transform-based time series decomposition model to extract really the seasonal signal out from the observation, which is shown in the middle graph. The seasonal signal here, you can see the pattern from the middle graph is very regular with both the daily and the weekly seasonality information, right? So the weekend is always different than weekdays. So this seasonal signal captures the failed connections from those continuous failing clients, which are so-called bad clients from the survey. Next, let's double-click into the bad clients.
So, Jisheng, before you move, go to the previous slide. So the way I look at this is, in their particular network, they have a set of clients that have a bad password, bad certificate, whatever. They're persistently bad, and they're consistently bad, right? And so the point of the decomposition of the pattern is to take these guys out, right? So these guys, first, they need to be fixed. In this particular customer's case, they absolutely want these, and they proactively go and fix these. But these are always failing. They're nothing new or news about them. Right. I guess the news is about these guys.
Yes. Yeah, but as you see from the survey, these are very annoying. This continuous failing client, they may not be business critical. Otherwise, I assume they are fixed at the first time. But keeping them on the network will just hammer your network. That will impact really the other business critical clients. So people are interested to know what are these clients and why they are failing. So you can see from this side, there are totally 293 bad clients. That's fine. Yeah, there are a total of 293 bad clients on this side, which is 7% of the total clients. It's a pretty noisy environment. And for each client connect session, in addition to just the success and the failure, we also send very detailed information regarding the connect session, like authorization, authentication, DHCP, together with their reason code to our cloud. So with all this granular information, Marvis can not only detect these clients, but also really telling you why they are fail and how to fix them. These are two good examples here. The first client you can see it fails association 24/7, consistent all the time. So this is a typical pattern of this called on-site legacy device. It's interesting today, we're talking about 11x new protocols. But a lot of retail customers, they still have those kind of 11B only device on the site. It just takes time to refresh them. So in this case, Marvis will give you the two suggestions. One is to disable them, even they are not critical, but don't impact the other users. Second, actually to configure a separate WLAN to enable this legacy compatibility for those devices if you still need them. The second client actually is different. This client actually does not present during the night and the weekend time. Also, this client fails authentication rather than association. This is a very typical pattern of this employee portable device, like a mobile phone, but with the wrong certificate. So, Marvis will just suggest the admin to notify the user to take care of it. So these are two examples. Most of our other 293 clients are like this. These are two examples, Marvis can really help user find the root cause and clean up their environment. Now let's move to the residual signal from the decomposition, as you remember. As Bob mentioned, we spent over 2 years of the time continuously investigating into this anomaly detection model. And we finally reached 95% accuracy with this neural network model called STM. Let me ask you a question. Has any of you who is interested about ML tried to build a neural network yourself here? Yes. You probably know. Actually, it's not that difficult. It takes only 10 to 20 lines of the Python code to build a model yourself, use the open source tools like TensorFlow or Keras. So that's not magic anymore. What really fundamentally differentiates us is how you tune the model and how you productize that model to solve real-world problems. So on the tuning side, in addition to neural network, we use multiple technicals like multivariate input, confidence prediction, random noise ingestion, to really help us improve the robustness and the accuracy of that model. So some of these technicals are patented. I'm not going to talk about details. But one thing I'm going to, because you asked the question, I'm going to really focus on is the productization of those models. So yes, we take 30 days of the data to train those models. And as I mentioned briefly before, to achieve, because every site is different, to achieve the best accuracy, we actually train a neural network model for each site. So it's not a one model per customer, it's one model per site. So this is number, actually here today, we're training and servicing 10,000 neural network models in Marvis. This is really the power of this cloud native infrastructure. But come back to your question, how do you handle the cost? The interesting, first, the 30 days of the data, there can be gigabytes, even terabytes. But after we train the model, the actual model we use to service to do this real-time detection is only 100 kilobytes per site. So this is this layered framework I mentioned. You take as much as data as the input, but you actually quickly filter down the volume of the data to extract only the useful information, use the ML, all of these things. And you reach actually some manageable size at the end. And also the training job is really heavy. It's a training once a week. Every week, we launch a 200 node plus cluster on AWS. The training takes actually a few hours, but it's just once a week. You finish it, you save the model in S3, then it will serve the real-time detection. Then come back to this example. You can see here, you can certainly see a big jump for both of the fed connection count and the impact user count at around 7 p.m. on October 27, which is a Sunday. So this is a very clear anomaly from the statistical perspective. But how do we turn this into a business anomaly? Or in other words, what should the user do about this? Anomaly is not actionable. To answer this question, we use something called mutual information to really troubleshoot each anomaly we detect. So mutual information is a popular method that people use in information theory to really measure the mutual dependency over two random variables use their entropy information. In this case, for each anomaly we detect, we measure the mutual information of various network attributes, like the VLAN, band, OS, with the values from this anomaly. So the higher the mutual information correlated with the value, the higher chance that network attribute is the root cause. You can see from this graph, Windows OS is very highly correlated with the failed connections in this anomaly we detect.
So the action should be to disable Windows from your network?
Not yet. Yeah, let me come to this.
Yeah.
Actually, the full story is interesting. It's a big organization. They pushed the Windows certificate update for all of the Windows devices. But these days, people like automation. They did it for all of the sites. But because of time zone difference, for some sites, the certificate got pushed before they become valid. So that's the reason why for those just a few sites, all Windows devices suddenly fail. So in this case, Marvis did not have the visibility into Redis log. What Marvis could do is to first notify the user with this anomaly with the minimum delay, and guide them to look into the Windows device, not disable them. It's more like, because we know it's a certificate authentication failure. We tell them all Windows device failed at this time, at 7 p.m. altogether, they should be able to find the root cause. But as I mentioned, we have the plan to get even the Redis logs, third-party logs into Mavis. Mavis should be able to correlate those events from different data sources and really even get to the final, the finish line in that case in the future. Okay, next let's look at another, as Sudhir mentioned, a 2-decade network problem called missing VLAN, which normally have very bad user impact. When a VLAN is configured on AP but missed from the switch port, user is pretty much black hole on that AP. You can connect to the AP, but you will never be able to get the IP or pass traffic. So the traditional way to detect the missing VLAN is to monitor the traffic going through the VLAN. If one VLAN continuously lacks traffic, then there's a high chance that VLAN is missed from the switch port. The biggest problem of this approach is false positive. You can see the number here. During 24-hour window, actually we detect more than 33,000 APs missing one or multiple VLANs because they have no traffic. This is certainly not true. The key gap here is not every VLAN is created equal. So there are at least 2 types of special purpose VLAN which can cause a problem for that detection. One is black hole VLAN. People create a black hole VLAN for the error traffic, like unauthorized user traffic. So yeah, black hole VLAN is supposed to be quiet and it should not be added to the switch port. The second example is what we call the over-provision VLAN. It's kind of the root cause similar like the Windows 3rd case. Large customers use some special VLAN for certain sites. For example, the legacy device sites, because the legacy device only present for certain sites. So those special VLANs should only present or is only applicable for those sites. But because people do automation, people want to keep config consistent, so they end up provisioning that VLAN for each of the sites. So then for the remaining site, those VLANs are not valid. You expect low traffic or no traffic there, and those VLANs should not be added to switch port. Otherwise, it may have the security issues or security holes there. So you can understand the key for reducing the false positive is really to identify the purpose of each VLAN. To do that, you can ask a customer that question, ask them to maintain a list, which is sometimes error prone. So in our case, we actually develop a machine learning model to automatically tell the purpose of each VLAN by monitoring the traffic going to the VLAN. So this is what is shown in the graph. Each dot in this graph represents a unique VLAN from a customer. So this graph represents all of the VLANs configured across all of the missed customers. So for each VLAN, we collect several features. For example, how many of APs has or lacks traffic on that VLAN? How many of sites has or lacks traffic? How busy is that VLAN minute by minute from all of the APs? So then we use another technique called PCA, Principal Component Analysis, to combine all of the features and map them into this 2-dimensional space. The interesting here, you can see different purpose of VLAN, high traffic VLAN, low traffic user VLAN, black hole, and over provision. They are separated very well. Even they are from different customers. The reason is just because the VLAN behavior actually is similar across different customers. So the beauty of this is we actually just build one model. Rather than anomaly detection model, we build one for each customer. Here, we build one model for all of the customers. So for any of the new customer, we don't have to ask anything. We can tell the purpose of their VLANs very quickly after they deploy. So this is really the power of this multi-tenant infrastructure. Every customer can benefit from the knowledge we learned from other customers. So as I mentioned, by precisely identifying the purpose of VLAN, we reduced the detection rate from 33,000 plus to actually only 607 missing VLAN, which are actually missing. So this is more than 98% reduction of the false positive. This is really what ML should do. So then regarding the actions, we have 2 sets of actions. For the Juniper switch, we actually give the user option to change their config to add the VLAN for them from the cloud. For the non-Juniper switch, we give them all detailed information like which switch, which port, which VLAN ID should add to guide them fix the problem there.
Before you move on, Jisheng, this actually speaks to really age-old problems that are pretty mundane can benefit from truly sort of unsupervised machine learning because they had no idea. We're not characterizing manually, this is a high-traffic VLAN, this is a low-traffic VLAN. So this is, for us, this is awesome. This is like Disneyland. We have so many problems that we can apply these tools to that we can eliminate, right? The best part, the cherry on top of this slide is 100% of these 607 VLANs ended up being factually true, right? When users went and added the missing VLAN to those 607 APs, right? Users now can get IP addresses and actually work. Right? This is the power of actually machine learning impacting the network experience to be positive, right? So thank you.
Yes.
That's better than 75%, right?
Yes.
That's 100%, indeed.
So just quick question on that.
Yeah.
I kind of go back to kind of thinking through how you're doing this right now, like via the SSH and stuff like that, so command line thought process. If you have the ability of informing, because you mentioned not just the switch, the type, the port, the VLAN, pretty much all the information somebody needs to go ahead and do something about it, do you have future plans, and I know this may be tweaked by the fact that you got bought by Juniper, but do you have future plans to do that same enabling self-driving on other vendor switches?
So let me answer that.
Yeah.
The way the framework is built, we're using actually open protocols, right? So there's nothing proprietary between the Mist Cloud and the Juniper switches. We're using OpenConfig, netconf, and open protocols. And so the entire architecture is built for beyond the Juniper switching platform, right? I'm going to leave it at that, but intentionally, we understand there's a much, much bigger realm out there if we can start to ingest this. And so in the spirit of getting this done, getting this right, productized, and then starting to expand the realm, very much possible.
Okay, last, I want to very quickly share some of the experience and the lessons learned from the journey of building Marvis. First, like I talked for previous examples, AI solutions should start from solving problems rather than applying models. Some of our other AI, vendors, they treat the AI more like a hammer, and they try to find the nails for the hammer. This is not going to work. Like this AI-driven support model Bob mentioned, for each support ticket we get, the customer support team, the first thing they do is come to Marvis, ask Marvis for the answer. So this helps a lot to prioritize these really top user impacting problems, which finally turn as a data science problem as explained here in Marvis. The second, if the goal of the AI is to automate and augment the human, then you have to keep the human and expert in the loop while you're developing that. So Marvis is continuous learning from the feedback from both the internal and the external customers. Actually, that's Marvis customer. The internal customer is the customer support team. They actually give a score, like you see before. For each question they ask, where do they find the answer? They give a score to Marvis. And also, we build various mechanics in our UI and the cloud to collect the user feedback. Both of this feedback are part of the foundation while we're building Marvis. Last but not least, building AI is really a long journey of the commitment and also the investment. So from the vendor side, it takes time to do it step by step from data, infrastructure, model, before you can finally solve the problem. And sometimes picking the right infrastructure and the data give you unprecedented advantage to the model building. It's also the similar example on the customer side. Adoption of a new AI solution requires trust building. Some interesting example about that Marvis action, since you asked the self-driving. When we first released this Marvis action, for a big customer, every suggestion we give them, they actually spend time validating them through different other data sources. But after multiple rounds of this validation, certainly come up with almost all of them are true positive. Now they consider to use a webhook to open support ticket directly from their NOC team. So really, in short, I think building AI solution is a long journey, and it's actually a joint work from multiple parties. So we just stay committed and be patient about that. Thank you.